Alright, in this video I'm going to be talking about DMVPN and how it works. DMVPN standing for Dynamic Multipoint VPN, or Virtual Private Network. And this is based off of the point-to-point GRE tunnels. And when you deploy this in a WAN solution, normally you would have something like R1 being the headquarters router, and then it has its little branch sites out throughout the world, and you would want to connect to them, but you don't want to pay, like, let's say, a VPN service through an ISP. Because if you already have an internet connection and then you have like a redundant VPN connection, you're paying double money. But in big corporations, you're probably going to want to have a backup solution. So your first option is probably that ISP VPN solution that they have a dedicated link to you, and then on the backup, just in case that link went down, you can use your redundant internet connection and connect and still have connectivity to your branch routers out there. So DMVPN is a great solution. And how it works is we create tunnel interfaces, GRE tunnels. And you can see here on the hub, you just go ahead and create tunnel 0 and give it an IP address. Whatever you want to use for your tunnel network. Okay, I'll get into that right there in a little bit. But how you set this up is you first create the tunnel interface, which I put tunnel 0, give it an IP address right there. Tunnel source, that's standard configuration on how to set up a GRE point-to-point tunnel. But instead of giving it a destination, you say tunnel mode GRE multipoint, because DMVPN, it's dynamic. It's a dynamic multipoint VPN solution. So you never set the destination when you set up DMVPN. It's always multipoint, because as more routers stand up, like let's say I stood up another router, R5, connect that into the internet, boom, this multipoint, as long as I configure R5 correctly, it will register with router 1. So this is just a very robust and modular solution, VPN solution out there. Okay, so first, do that whole tunnel source, tunnel mode, GRE, give it an IP address, cool. Now we go into the steps of configuring NHRP, which is the next hop resolution protocol. So these branch routers can dynamically register with the headquarters router, and they can monitor each other, monitor routes as links go down and up and stuff. The headquarters router will know about it. So first thing you need to do is actually, let me clear this up, is give it a network ID. Something unique to where not just any other router could join this DMVPN network. So give it a unique ID. You could even set it up with authentication, but in this network I did not. And then also you are going to need to do, on the hub router only, IP NHRP map multicast dynamic. Now what that does is it allows NHRP to automatically add spoke routers to the multicast NHRP mappings. And since we are going to be using a dynamic routing protocol to learn routes from all of these routers, it's also going to allow us to send multicast packets to our branch routers. So like in this case, I'm running EIGRP, and the whole thing about EIGRP being a distance vector protocol, I need to turn off split horizon. That's one of the rules if you're going to be running EIGRP over a dynamic multipoint VPN and you have this hub and spoke solution, which we have right here, hub and spoke, then you need to turn off split horizon. All right. Now after that, that's basically all you need to do for setting up the hub. But if you want to go into phase 3 of dynamic multipoint VPN, then you need to turn on IP NHRP redirects So router 2 doesn't always have to go to router 1 to connect to router 3. Since these are all geographically separated, why doesn't router 2 just go through the internet and connect like that? It doesn't have to always go through the hub and then go back down. Because if router 1 goes down, then that's the whole point of this hub and spoke. Like, that's a bad solution. But in phase 3 of DMVPN, spokes can dynamically send traffic directly to other spokes. And that's the whole thing about DMVPN phase 3, spoke to spoke connection. So you're going to turn on redirect, and then this whole TCP adjust MSS 1360, that is just trimming down the maximum segment size at layer 4, so the packets will fit into a normal 1500 megabyte packet, so it's just not fragmented. So you can set that up there. Other than that, that's pretty much all the configs you need to do for DMVPN. The spokes, very similar, but you have to do a static mapping on who the next hop server is going to be. So on the spokes, we have to put IP NHRP map, and then this right here, 192.168.0.1, guess what? That is the tunnel IP address of the hub. And then this right here, this 15.15.15.1, is the physical non-broadcast multi-access IP address for that interface that actually connects to the internet. So that has to be a public address. And then we have this command right here, IP NHRP map multicast 15.15.15.1. That is a static mapping to send multicast messages to that address right there. So you got to put that in there. The whole network ID thing, the whole network ID thing, well, again, that needs to match what the hub has. This is where we say 192.168.0.1, which is the tunnel IP address of the hub. That is the next hop server. You can see right there, NHS, that stands for next hop server. And then the line below it, IP NHRP shortcut, that is what needs to be on all spokes, so these spokes can talk to other spokes directly. All right. And then you can do the same thing, IP TCP adjust maximum segment size 1360, and these are just the standard configs right here for the tunnel interface. All right. That is basically how, that's the configs for it. But now let's go into the CLI and let's actually do some packet captures on these routers registering with the hub. All right. So let me start Wireshark up. Shrink this down. And let's bring up router 2. And we'll do it with a no shut. I'm doing no shut. This is already on the tunnel interface. And once I do that, you should see some NHRP messages here. Here we see the physical address 25.25.25.2 sending to the hub, which is the public address of 15.15.15.1. And we have an registration request. So basically, I'm giving router 2 is pretty much telling router 1, here's my tunnel IP address, here's my physical IP address, now you know about me. Then router 1 is going to send a reply saying, yes, it's almost like a confirmation, now I know about you, and then everything else is going to happen. EIGRP, I'm going to start sending multicast messages to you, so on and so forth. All right, and then if I just do the same thing and bring up routers 3 and 4, do the same thing. Routers 3 and 4 now should be sending these registration and requests. Let's see here. Did I capture it? There we go. So now everyone knows about each other. Well, actually, I'm sorry. Router 1, the hub, knows everybody. and let me do a show IP NHRP. There we go. So these are the dynamic mappings. You can see here, dynamic, dynamic. I know about these tunnel interfaces of each of these routers. Okay. Now I'm also running EIGRP, show IP route EIGRP. And these are loopback addresses that I have on each router. So I'm learning them via EIGRP. Cool. And look at their next hop IP addresses. And if I were to ping it, let's say ping 2.2.2.2 from my loopback, source of 1.1.1.1, it works. Sweet. Now let's see what the routing table and mappings look like for router 2. Go to router 2, show IP route. Let's clean that up. Alright, so I'm learning some routes via EIGRP, because you can see here with the D there, and notice that the next hop IP address is 192.168.0.1. That is the hub right there, this guy right here. Now I thought you said that these spokes will talk to each other directly. They don't have to go through the hub. Well, I just learned these routes via the control plane, but what happens if I actually send data packets? So let me send some data packets to router 3. Ping 3.3.3.3. Cool. Got it. It works because I know how to get there. But let's do a show IP route now. Show IP route. What looks different from above for this network right here? Scroll up, and then there you go. There was something right here that looked like a percent sign. And if we look at our legend, what does that say? Next hop override. So let's do a little bit more snooping. Show IP route next hop override. And then it'll show me all my routes that I have next hop overrides with. And here, for that 3.3.3 network, I learned of a better way to get to the loopback of router 3, and that's actually going via the tunnel interface of router 3, 192.168.0.4. If I were to do this for 4, I would be getting that same result as well. And there we go. And I'm running DMVPN phase 3. Again, let me step back away from all of the details on this. Dynamic multipoint is just a WAN solution to connect to other sites across the world, across the internet, anything. And you don't need a dedicated circuit by the service provider. You just need to have an internet connection, basically a public IP address, and then you can just set it up there. Okay, so I hope this was informative for you, and I'd like to thank you for viewing.